you, Richard.
Great. Should we kick off at 6 o'clock? I'm recording.
Yeah.
Polly, just from the comments, it looks like a couple of people don't necessarily have the whole thing, but that might be their own view settings.
Yeah, if I'm sort of doing a full screen share, as far as I know, can everyone else? Let me just see. Maybe that's better. It's my fault, probably. Is that any better for people?
I think we set off, and if people do have a problem, if they can use chat to say what the problem is, well then that will, then if there is problems, if we have to, we can stop and try and sort it.
Absolutely. Yeah, I've just skipped forward. Okay, so Andy, go for it.
Okay, does Jonathan want to have a quick...
Oh, yeah, sorry, Jonathan, you were going to come and do an intro.
Yeah, cool. I'm not sure I'm able to start my video, but...
I don't know, the video settings seem to be a bit weird.
I think you have to make me a co-host.
Oh, it's because I've made Florence and Andy to do that now.
You can do. If you can't, then I'll just talk without video.
Sorry, Jonathan, I feel really... Let me try it. Let's see what I can do. A second. I don't think it's giving me the option.
Okay.
Yeah, I think it's because I've already got them assigned.
Yeah.
Sorry.
No, that's okay. So my name's Jonathan. I work at the Carbon Co-op. I'm actually in the office at the moment, although I'm the only one in the office. Because there's a lot of people here who come from out of our area that we usually work in, which is the Greater Manchester area, thought it'd be just good to just briefly introduce Carbon Co-op and what we do. We're a community energy organisation, so that's not for profit, and we're based around our membership really. And the main aim of the organisation is to help our members and the wider community to make significant changes and reductions in the amount of carbon people use in their homes. And really the core aim is around tackling climate change together, basically collectively, and doing so in our homes. And the idea of the cooperative is, as a cooperative, we're stronger together. We can broker access for members and for wider community to technical services and expertise, to trusted contractors and projects and offers and all sorts of things. But more than that, really, it's about creating a community of interest, really, and a community of people all working towards a shared aim, really, and like-minded people. And most of our members are people that are retrofitting their homes and are in that process at the moment. But we also have people that join the Carbon Co-op because they've already retrofitted their homes and they want to share that experience and knowledge and expertise. So a key part of what we do is brokering that process of peer learning and sharing and knowledge exchange. And really that's where Andy comes in. Andy joined the Carbon Co-op really, well, I'm speaking on his behalf, but I think to share his knowledge and expertise of all the work he's done. And we, as I said, we work in retrofit and we work in energy efficiency. And up until a few years ago, we were, I'd have to say, very skeptical about heat pumps. We were skeptical about their performance, about how great an impact they could have on decarbonisation and how well they performed in relation to gas, really. And that has really flipped. And one of the reasons that has flipped now is due to Andy, his expertise, demonstrating that heat pumps can work effectively and that with appropriate knowledge and expertise, they can be specified properly and they have a role in the mass decarbonisation across the UK, across heating. And for us now, we're at the point where we're saying, when we're specifying new retrofits, part of our My Home Energy Planner assessments, we don't want to specify replacement of gas boilers because really it's not climate compliant and it's not the future we want to see. So yeah, that kind of tees up the context for tonight. I'm going to just leave you with two things. One is people-powered retrofit. That's a service we offer now mostly in the Greater Manchester area, although we are offering a little further afield as well. It's an end-to-end service for householders, and we help people with advice, assessment, retrofit coordination, linking up with contractors. And yeah, it's an end-to-end service, and people like Florence has been involved in that, and you'll hear from Florence in a bit in helping us deliver that. So if people want to do fit heat pumps as part of a whole house retrofit, then do talk to us and do let us know if you're interested. The other is the Green Home Grant Scheme that was announced in the finance statement last week by the government. £1 billion to be spent between now and 31st of March, £5,000 per household. Very exciting, very interesting, lots of potential. One thing I would say is there are a lot of question marks around the scheme, how it will be delivered, what measures will be eligible, what advice and design and other complementary services will be eligible under the grant. I'm pleased to say we're working with BEIS at the moment to help them define that and how it's delivered, and to encourage them to go for whole house and things like heat pumps and what have you. So what I would say is it's very exciting, it's very interesting, the detail is lacking, and as the detail becomes more apparent, we'll let people know. We're going to be running a webinar on the scheme when we have more information on the 14th of August, but do look out on our website and on social media as well, and we'll share more information as it becomes apparent. So that's my bit really. So I'm really happy to hand over to Andy, to Polly, and to Florence.
Okay, thank you, Jonathan. I'll do a very quick introduction, and then Florence and Polly will also do an introduction. I've been into retrofit, and before retrofit, it used to be called renovation. I got my first renovation grant, did the plans and stuff in 1969, so you can tell that I've been hanging around for a long time. And I've done this all my life, and then the last, well, at the end of my life, I've ended up being a reader in urban sustainability at Salford University, and also a consultant to the European Commission. And I think that's enough detail from me. I'll pass on now to Polly or Florence.
Florence, if you want to go next, that's fine.
Yeah, sure. Hi everyone. Great to see so many people joining us tonight. I'm Florence Collier, and I'm a low energy designer, passive house designer, and mechanical engineer. So I'll be just helping out with the course in terms of a lot of the theory. Mainly, I haven't seen a heat pump installed, although I do know of some, and I've seen some installations. And you'll be hearing a bit more from me in sessions 3 and 5 probably, but I might interject every so often just to complement Andy's presentation tonight. And also I'll keep an eye on the Q&A and jot a few things down while we go along. There we go.
Thanks, Florence. So I'm helping facilitate this session. My name's Polly, by the way, just in case you wonder, as I'm up here as Carbon Corp. So I work with the energy systems team primarily at the moment on a project based around looking into demand-side energy, so how we can aggregate and shift energy use to help decarbonise people's electricity consumption. It's a bit different, but it's all kind of under one roof, as it were. I'm also really excited to be doing a bit more work on events with members and sort of enabling more of these trainings and these Skillshare spaces to emerge, which is really, really exciting. And yeah, just sort of maximising the collective knowledge really of our members at Carbon Corp, and just supporting knowledge sharing more and more. My background is very much based around climate justice. Worked with Friends of the Earth prior to Carbon Corp, and I've worked for a couple of other co-ops as well, helping them set up community-led events programs and design participatory trainings and projects which have wider social benefits. So it's fantastic working with Carbon Co-op because there's a lot of parallels with my previous roles, and it's very member-led, which is really great, but with much wider sort of impacts built into the work that's happening on the ground. So there's a lot of tangible stuff going on, which is very exciting. And obviously in the recent sort of grant announcement, there's a new context for which, you know, we can hopefully work within and enable more people to take advantage of this window of opportunity to install not just heat pumps, but hopefully, yeah, have an opportunity to decarbonise some of their home energy systems in general. So without further ado, I'll hand back over to Andy to start the presentation.
Yeah. But before I actually start the presentation, a very quick thing about session 4, because we haven't mentioned that. Well, session 2 and session 4. Session 4 is going to be very much about retrofit, which I know Marion Hislop and Liam are doing. And
Yes.
I'm sure Marion will you know, will be telling you about the retrofit she did as part of Carbon Co-op, which I think was a very brave move to help people doing, you know, a series of retrofits. So it's actual practical stuff rather than telling people about it. So that should be good. And if Tristan's here, he can tell us about session 2, or shall I say, talk quickly about it?
If you want to mention session 2, that's fine. Go for it.
Okay. Session 2 is Tristan Lee. He did a brilliant retrofit, well, installation of a heat pump. And it was, you know, because he's a good engineer and so on, he managed to get a COP of 4 straight off. You're going to hear all about that next week. That's a good example of how to do it. I will tell you about what I've done, which was more sort of muddling through, as it were. So I'll kick off now then, because we're getting a bit right.
We're getting a tiny bit behind, don't worry.
Yeah. Aim and objectives. So the idea behind, as I see it, is that in all these courses, in all these sessions, we're looking at how heat pump technology can be part of a retrofit system. Okay, so it's not just about heat pumps per se, because I know that some people are very proud of their huge heat pumps, which they, you know, spend a huge lot of money on, and it's much more about running heat pumps efficiently, and if you like, running a low carbon house as a retrofit. So what we have to know about is what is an effective heat pump system in retrofit, and I'm hoping to give you some idea of that, and Tristan will give you more. This thing about why do heat pump systems fail, that's very important. A lot of systems do fail, and it's no point in ignoring that. I would say at the moment probably more than 50% of heat pumps don't come up to expected performance, as it were. So then the last thing, the criteria of effective heat pumps, is very important. What are the criteria? What makes it work? And for that matter, how do you apply the criteria? Okay. Next, there we go. Right. So you'll hear me mention John Cantor, good friend to me, and also to Tristan, incidentally. That's how I met Tristan, because he was working with John Cantor. Right, okay. His book is out of print at the moment, Heat Pumps for the Home. And I understand actually a new copy is coming out. It's as you can see, it's 2011, and I think there will be a 2021 edition. However, you can find it if you go onto John Cantor's website. You can find information about it, and you should be able to get an electronic copy. Another place for good information about heat pumps is the BRE group. And that website there. Okay, next slide. Right. Okay, we know that zero carbon heating is needed to avert climate change. Zero carbon housing is needed to avert climate change. And the question is, can heat pump technology be part of this solution? Now, many retrofit architects are still skeptical about this, reject heat pumps. And actually, this is because they've had bad experiences with heat pumps. So in a way, I want to put from the start a bit of a cautionary tale here that you have to work hard to get your heat pump right. Kindle edition. Oh, right. Okay. Apparently, you can get John Cantor's book on Kindle. Great. So yes, so we must always bear that in mind, that you have to work hard to get in terms of heat pumps. Yeah. Next slide. Right. Okay. Well, our housing stock is old. It's one of the oldest in Europe, actually. Poorly insulated and inefficiently heated. But 80% of the buildings will still be in use in 2050. So we have to treat these, it's no good relying on new houses. We have to treat existing houses. And that means treating 2 million homes per year. And that's a huge ask, actually. That's a fantastic amount of work. But we have, I think it's about 23 million houses or 23 million homes, and 20 million of them do need heating. And we're already most of the way through 2020. So it's at least 2 million homes a year. So big job. Right, next slide. Right, just a little bit of history here. UK, we had Green Deal and its take-up was about 1,000 homes. Now we've got another, if you like, another idea of, you know, trying to make houses green coming up. And I just hope we do it better than we did Green Deal. So that's something, well, as Jonathan said, you know, we'll be watching and we'll be studying what's happening. Green Deal is actually part of an EU initiative. And in Germany, I've done a lot of work in Germany, so I get all this stuff. In Germany, they treated 3 million homes by 2013. 74% average carbon reduction, which is a lot. I think they're aiming for 80, but to get 74% is pretty good. One of the key things was that they had quantitative easing for people who wanted to do renovation, i.e. low interest rates, 1.5, whereas in the UK, the interest rates were set at 7% for money from the government to do your home. And of course, a lot of people realized it just wasn't worth it. That 7% is higher than they'd pay on a mortgage. Anyway, the other thing in Germany was they had subsidized insulation if you put in more insulation than the building regulations in Germany asked you to. Yeah, that was the reason why the German system was so much more successful. Yeah, next. Okay, I'm coming on now to my experiences. And I installed a water source heat pump in 1994. And I was actually at the time doing sort of energy loss reduction by insulation and also things like solar gain. But then to continue the story, I've put an air source heat in 2010, and modified it over the years, and I'll tell you that story as we go through. Yeah, next slide. Right, well, the story began really when I met John Cantor. I had an idea of what heat pumps were, but I met him in CAT, Centre for Alternative Technology, in 1993, and as part of the AECB, Association of Environmentally Conscious Builders, who are effectively retrofit pioneers. I really liked John, who had a really practical attitude to heat pumps. And so in 1994, I effectively became his apprentice. He built me a heat pump out of basic components. He bought the compressor, bought all the other components, and built this heat pump. And it was fascinating for me to see that happen and how he put it together. That was using the spring water supply that I've got for my house. Next slide, please. Right, so what was this water source heat pump like? It was quite small. It was only 3 kilowatts, partly because there was only, I think, about 15 litres a minute or something of water coming through. So it couldn't be big anyway for a water source heat pump. Required heating for the house at that time was probably about 5 kilowatts or more, but this didn't actually put me off because I had a wood stove, which I'll tell you about, and also I knew then that heat pumps are much better if you can have them working as long as possible. As you'll hear me say several times over this course, oversizing a heat pump is bad news. You just don't get the efficiency out of it at all. Right, and the other thing with heat pumps is if they switch on and off, you don't get, they don't work properly and they become very inefficient. So on my heat pump, it had a one hour delay in it, so that when it went off, it wouldn't come on again for an hour at least. And that meant you stop the switching on and off thing, which makes a lot of heat pumps very inefficient. I'll show you that in session 3. I had underfloor heating as well as radiators. You want as many heat emitters as possible with heat pumps. So the combination works well. I chose a 39-degree flow temperature with, John's recommendation. Ideal for the underfloor heat. It was a 100-meter coil under the living room floor for that. 750 watt compressor. Water source came out at 9 degrees centigrade, and after heat had been extracted from it by the heat pump, it then went out of the heat exchange at 3 degrees centigrade. So essentially that's where a lot of the heat that went into my house came from, the fact that the water source was 9 and all the heat was taken out from the water before it's discharged at 3 degrees. Okay, next slide. So the heat extracted from the water was 2.25 kilowatts. Okay, this is low, and that was by the compressor, which was 750 watt or 0.75 kilowatt compressor. So the total output of heat, that's from the water and the heat produced by the compressor, was 2.25 plus 0.75, i.e. 3 kilowatts, which is what I said earlier. Coefficient of performance. Well, for this system, it was fixed at 4. 3 kilowatts, the total output of the system, divided by the input, which was 0.75. It's fixed because the temperature was always 9 degrees and it was always static extraction, 9 down to 3. And also the compressor itself wasn't like in modern heat pumps, the compressors are variable. So you can run them at a lower speed and whatever, but they run more efficiently. If you have a fixed compressor, which this one was, it's a more simple system and it's actually more efficient. Great little system. Unfortunately, I had a problem with the water source. The water was, I was getting less water out of it. And as it reduced, I was finding that danger was just freezing up, and then you just had to wait a whole day for all the ice to thaw. So it really became wasn't viable. So there was a need for an alternative heat source. And that's when I decided to go for an air source heat pump. Yeah, next slide. So what I'm doing now is I'm going to actually go through the whole Nook retrofit. I've told you about how I got started in this, the initial heat pump, which I was proud of, and I kept in touch with John and talked to him about the heat pump and, you know, when it failed, about how to get a replacement for it. But also I'm going to mention briefly insulation, airflow control, solar gain, which is important to this house, thermal store, the PV array, and of course the heat pump installation. Yeah, those will come up in the next slides. Somebody asked about, yeah, if you've got an ordinary gas boiler, I think it's about 50 degrees. So heat pumps are a lot cooler. You know, they reckon 40 degrees is a good temperature for a heat pump. And if you can get below 40 degrees, you're getting greater efficiency. This is a photo of my house. You'll notice it's got a south-facing conservatory on it. And actually in the spring, that gives me quite a considerable solar gain. It really does keep the house warm. And actually keeps the temp as well, which is important up in the Pennines where I am. Yeah, next slide. Okay, I won't spend long on this, but this is just the whole picture of the house with its, I've got a PV shed, with PV panels on the shed. I couldn't put it on the house because they were old stone slates, and I would have got complaints as well, I think. I've got the water tank there, which is I've used for my water source. Built in 1750, external walls 550 millimeters thick, and water shot masonry, which is a particular type of masonry you get in Lancashire, which actually, if you like, sort of it slopes the water out of the house. But I won't go into that. It's a detail I can talk about another time. And yeah, the details are there. So I'll go on now and look at other details. Right. So insulation is important. There's no point. There's a really big heat pump into a house. You're going to put a lot of energy in to run the heat pump. So you try and make your heat pump as small as possible. And the way to do that is to reduce the load of the heat pump by putting in insulation, putting in conservatory gain, all sorts of other stuff. In my case, I had a highly insulated extension built on the north side of the house by an AECB passive house contractor. So it's pretty much to passive house specifications, right? And what that did was it converted the original north face of the house into a 28-ton thermal store, as you'll see on the next slide. Right, there's the new extension. As I say, pretty much to passive house standards. Behind that extension is the old gable end, and there's 28 tons of stonework there, and that is a very useful thermal store. It means that if I turn off all the heating in the house, because I've got that massive store there, the house just, you know, over a day it will be okay without any heating if everything's turned off. And yeah, we'll go on from here. Somebody's just told me their gas boiler operates at 65 degrees. That's fine. I mean, 50 to 65 degrees is normal for gas boilers. But for heat pumps, you really want to try and keep to 40 or below. Most of the heating for Bank Nook supplied by an air source heat pump installed on the west elevation, 2010. Next slide. This elevation actually catches a lot of sun, and there's a bit of heat comes off the wall there as because the faces across the valley. And actually this does help. You know, if you can get your heat pump into somewhere where it's a bit of a sun trap, the air is warmer going into it, so you get a little bit of a gain that way. Yeah, next slide. Yeah, this is the internal bit of the heat pump. So you've got your control panels here, and you can see all the plumbing. I've got a lot of circuits on my heat pump, because if you're running it at a low temperature, you need to recognize that you know, as the water circulates, it's going to go down. So if it's going down to, you know, 25 degrees or lower, well, then it's not giving out much heat at all. Another thing I will say while we're looking at this slide is that I've continued with insulation. This is actually in the cellar, and now in this cellar, where you see that dry stone wall with the window there, that 150 millimeters of hemp lime on it, which is very good for putting in cellars. And there's other insulation I've put in since then, but I'll talk about that another time. Right, next slide. Okay, I put in a 5 kilowatt output Ecodan air source heat pump in 2010. When I put the heat, well, the people who installed the heat pump told me I needed an 11 kilowatt heat pump, and I said no, I definitely don't. Then they said, well, you must have an 8 kilowatt heat pump, and I said, well, no, because I'm, you know, designing it for an output of heat from my house of 5 kilowatts. They said, oh yeah, but you know, you'll have problems. And I'm very glad I stuck out for a 5 kilowatt heat pump, because it actually works efficiently because it's 5 kilowatt. If it had been an 8 kilowatt one, I could never get the efficiency out of it. And incidentally, I recommend to everybody to try and make their house what I call a 1 kilowatt house, i.e. you have a heating system that takes a kilowatt, and with a 5 kilowatt heat pump, it takes a little bit more than the kilowatt to start off with. But then it soon settles down to about a kilowatt. So I think that's a good thing to aim for, because, you know, we need metrics for how efficient we're going to be. And I think a house that in winter is only taking 1 kilowatt for heating isn't bad at all. considering that some gas systems are putting out 20 kilowatts or whatever. Different. Yeah, I upgraded the underfloor heating, so I've now got 60% of the floor area of the house as underfloor heating. The operating water flow temperature was set at 35 degrees. Right, I'm going to come on in a bit about calculating your heat output and whatever from your house. That's a specialist task, and I'll say something later. Right, so operating water flow temperature 35 degrees, and I put the system in. I think when it first went in, it was about a COP of about 2.7. However, I tuned it up in 2011 and put a new controller in it, which I got this free from Mitsubishi. Actually, they're very good when I first had this, because they were encouraging people on the test. They're encouraging all those people who were test sites. Okay, next slide. Right. In cold periods, when the air source heat pump becomes inefficient, I use a wood burning stove that gives additional heat and hot water. I know some people saying about pollution from wood burning stoves. They are getting better. You can actually get downburn wood burning stoves now that do meet the 2022 standards. And the other thing about the wood is where it comes from. If you're shipping it across from America, that's not very low carbon. Been very fortunate to have space around my house, and I planted 2,000 trees there in 1977 to 79, and that gives me a ton of wood a year. Actually, I tend to burn slightly less than that now, but yeah, around that anyway. Okay, next slide. So for the heating season 2013-2014, I achieved a COP of 3.61, which I was very pleased with, actually, and it was about the best COP. I think it was the best in the trial that Mitsubishi were running. And you notice there that I've raised it from the 2012 figure of 3.12. What I've done is, because I've had all the monitor information from Mitsubishi, that has allowed me to consistently over the years monitor what's happening and then make changes in response to the information that I've got, finding out how the heat pump worked best, and then operating it in the right way. For instance, they work better if you bypass the thermostat and work them on a timer. So you put it on for 2 or 3 hours, turn it off, and then have it coming on again at another time during the day for 2 or 3 hours. But I will say more about that in session 3. So anyway, here, there's about 8,000 kilowatt hours heat output with an input of 2,25,000 kilowatt hours. Yeah, so what we'll do next is to have a look at some of the monitoring data, and that will tell us more about what's going on. Now, unfortunately, this graph, you have to be, I don't know if you can see that there's a green line. That's the one that goes right down. That's the coefficient of performance. So it goes down to 0 in August because the system wasn't used at all in August, and then rapidly comes back. And you can see in the winter where it's quite high in the autumn, goes down in the winter when the temperatures are low, and then rises as the temperatures get warmer. But some people worry with their air source heat pumps that they perform badly in the winter. There's not a huge difference. It's still giving me above 3 p in the worst time in the winter. And again, I'll say more about that because there are things that happen once you go below 3 degrees centigrade. But, you know, that's details for, I think, again, session 3. The orange bars are the heat output and the blue bars are the heat input. So you can see there where, you know, in the winter, yes, the orange bars are at least 3 times what the blue bars are. So it's overall, it works, as it were. Okay. Right, next slide. Right, so to try and summarize about the heating from all sources, the heat pump gives out, I find a megawatt hour for me is a useful unit, right? You can talk about your house, and a lot of houses will take about 10 megawatt hours or whatever per year to heat the house, or 50 if you haven't done any insulation. My house, yeah, the heat pump puts in about 8 megawatt hours. The stove provides about 2 or 3 megawatt hours, and the solar gain from the conservatory, I reckon, is about 1.5. That's really a guess. But what I can tell you is that if you've got a greenhouse positioned to the south, the heat coming through that greenhouse at midday on June the 21st, if it's sunny, is about 1 kilowatt per square meter. So solar gain can be a really good source of heat. It can also completely overheat a building if you get it wrong. So if you're putting a conservatory in, make sure you have opening vents. I've got big double doors on mine, whatever. Okay, so my house is at EPC C. I'd prefer it to be better than that, but because it's a stone built house, that's really not bad for that type of house. Okay, so we'll go on now. Next slide. That's the PV array. I couldn't put it on the house because, well, for various reasons, shading from trees, and because there were stone slates. It actually makes quite a good shed. I keep my wood in the shed, and the wood is heated up by fans from the greenhouse. So the greenhouse gets hot, and I extract the heat from there and pass it over the wood that dries it. And also, I chose the optimum south-facing position, so I would get the maximum I could off the panels. So I get a very good return on my panels. Okay, next slide. So in terms of if you like, an audit for my electrical energy. I've got no gas or anything, so it's just electrical energy from the grid. It's the heat pump takes just 2.2, something like that. The 2.55 kilowatt array gives out pretty much 2 megawatt hours per year. And therefore the output, the net input over the year is about 1/4 of a megawatt hour. However, there are all sorts of transmission losses because I'm going backwards and forwards from the grid. And also there's the issue about the fact that I'm consuming a lot of electricity and heat in the winter, and then producing it in the summer. In actual fact, that isn't a problem. A lot of people are, some people think solar panels aren't useful because they only provide heat energy in the summer. In actual fact, in work done in Germany and the Combi craft work projects tell you that it's possible to combine all these different green heat sources. We're talking about biofuel, wind, offshore wind, hydro, and run the whole of your heating system, the whole of your electric system from low carbon sources. In Germany, they know this, and they are putting that into practice. And we can do it here. The government, isn't, well, I don't think they're on the ball about it, but the Centre for Alternative Technology, in their report for the Zero Carbon Britain 2030, have actually taken similar principles to the German Combi craft work, and they've shown that this is possible. Okay, and of course I have actually carried on with insulation, and so the energy input has reduced as I put more insulation in. I also did some extensive modifications in 2015 to the heat pump system. Next slide. In 2015, I did a review of the radiators. I did some very close calculations on the sizing of the radiators. I'd actually replaced the old radiators, which were over 20 years old. A lot of panel ones were placed with double and triple panels. So I put up the heat emitter system, as it were, so that the whole system worked very well at temperatures below 5 degrees in terms of flow temperature, i.e. the radiator temperature. Underfloor heating coils were flushed. System retuned to work at 30 to 36 degrees, but in actual fact, because I'd put all the radiators in, a lot of the time it was around 33, 34 and crawling up to, 35, 36 after the system had been on for an hour or two. So yes, that worked well. And so we go on to the next slide. So that gave me a performance for December 2015 of which isn't the coldest of winter months, but it's definitely a winter month. And I got a COP of 4.3, just over. External temperature of 7.5. Unfortunately, I haven't got an analysis of the season 2015 to 2016. After Mitsubishi being really helpful when I first joined the field trial, without telling anybody, they obviously had a policy change and they switched off the whole system, which meant my monitoring system was switched off as well, because it was part of it was a system where the information was sent to Mitsubishi and I got it back over the internet. But as I say, that was switched off midnight 31st of December. So I'll show you on the next slide what my last month looked like. Okay, here it is. You'll notice that the wavy green line going up and down is way between 4 and 6, and very rarely goes below 4. This is in December. There was some cold weather. When the temperature went down to around 3-4 degrees, you can see there was a big dip as the blue line, the wavy blue line went down. You'll notice the green line followed it. So the COP then was below 4, but for most of the month it was well above 4 and sometimes above 5. Again, the orange bars are the heat output of the system, and the blue bars are the heat input. So you can see there you've got quite big orange bars compared to the blue ones, as it were. Yeah, so it worked well, but I don't know I can't say what the overall coefficient of performance is for the year. I would guess that it is about 4. If it'll do 4.3 in December, over the whole year, it should be about 4, possibly a bit more. I don't know. Okay, next slide. Okay, a little bit about comfort, because the type of future we're going to, it's going to be a low carbon future. It has to be, unless we take the option to fry, but I don't want to fry. I prefer to be comfortable, and it can be comfortable. I really like my heating system. They say the best heating systems are underfloor heating, so you've got warm feet, cool head, and that feels comfortable. Incidentally, if you're anywhere damp, and I'm damp in the Pennines, 250 meters up, if you've got underfloor heating, it drives out the damp. So it's very good from that point of view. The stove provides extra warmth on cold evenings. You don't have to have a stove, and perhaps if you're in a town, you might say, well, actually, it's not going to fit for my house. I will show later that if you've got something like a fan heater, that's also a fine addition to a heat pump. In fact, if you go onto the BRE site, they discuss that in their sections there, talking about sizing of heat pumps and using augmented heat pumps, right? And it makes it efficient. Having a high thermal mass really helps, because it means that I can turn the heat pump off for 6 hours, 10 hours, or whatever, and I've lost, it's gone down by about 1 degree or 2. So that is useful. Other systems, there might be other ways of, if you like, providing a buffer with hot water tanks or whatever. Okay, next slide.
Andy, can I just interrupt you briefly? We've yet to have an interval. I just wondered if people might want to take the break. I sort of thought it was we were scheduling it for about 40 minutes in. We still want to do that? Because
right,
we're running quite ahead of time because we've got the session booked until 7:30. If people want to have a break, otherwise, if people are happy for you to continue.
If people are happy, I've got a few slides. They're only going to take about 5 or 10 minutes. I'll try and finish by 7.
No, sorry, Andy. I think it was an interval so that people can have a moment, have a comfort break, and then come back and finish the
right.
slides.
If everybody wants a comfort break now, I mean, since we're on the subject of comfort, appropriate. That's fine. And then I'll do that.
Is that okay with you guys? Just because when we planned this originally, I think we thought 40 minutes and then break and then continue. Fine. But I'm more than happy to be flexible if other people are all right. And we can review the questions.
Yeah, I'm fine if you keep your presenters in order.
Okay, I felt bad interrupting. But if people want to sort of reconvene about 7:05, give people a moment to make a cup of tea, have a comfort break.
Yeah. Okay.
All right. No problem. Sorry to interrupt you, Andy. I just thought people might need that. Problem. It's that time of the evening. Okay.
Yeah.
Brilliant. We'll speak shortly at 5:05.
Right.
I'll keep the screen on. No worries.
Yeah.
Andy, whilst people having a break, there's a few questions in the Q&A.
Right.
Somebody said, I can't remember which way around your graphs were because I was keeping an eye on the chat, but someone said, is it not more correct to say that the blue bars on your graphs are energy input rather than heat input, as you've been saying? Is it?
They are correct on that. That's me, not concentrating. They are energy input. Yeah. And I tell you what, Florence, if I don't mention that later, if you can ask that question, what I'm going to do is, because I've only got a few slides actually, so it's only
close to finishing
or whatever, and then
you can have a big debrief.
Go through all the questions.
Yeah.
I think that's perfect because there's a good 9 or 10, aren't there, in the Q&A box, and we've got someone with their hand up as well. Nicola Gilbert had raised their hand, but I'm not sure at what point because I'm not able to see the chat during the presentation. I don't think there is a way to do that. Did Nicola?
Oh yeah.
Polly, Nicola have asked a question in the other chat box, even the main chat. Sorry, Andy.
Yeah, can you give me visual when we come back, so that particularly at the end of the presentation. It's just been nice to...
Yeah, absolutely. So once I've stopped screen sharing, we can we'll have the bandwidth because I noticed there was a little bit of an issue with breaking up of sound. I don't know if that was just on my end because my internet's very patchy.
Okay.
You were cutting out a bit.
I had a little bit of that as well, I'm afraid.
You heard it. I messaged you, but your phone's on noise mode, so I'm really sorry about that. But yes, so I probably should have paused the recording, but I didn't want to, I didn't want to disrupt you by mentioning it, because we could hear you mostly. It's fine. These things happen with webinars.
Somebody has said that the sound's a bit flaky.
Yeah, unfortunately, it's. I think if that's why I was keen to sort of have our videos off because it really makes a difference sometimes.
Yeah, fine.
And I know you're in a rural area like myself. I think being rural doesn't help much with the internet.
Polly, did you know your video was still on? Your camera's on. So maybe if you are you able to click your camera off?
Oh yeah, of course I can do that. I can stop my video. But I think the other issue is that maybe my bandwidth isn't as good either in general.
That might make a difference.
Yeah.
Also, somebody's asked Polly if there's going to be some kind of CPD certificate. I wasn't.
Okay. We could definitely issue something, but I don't know in terms of like it being an official qualification. I think we're not obviously being, the position is that we can obviously say, you know, people have taken part in a course, but it wouldn't in any way be, you know, an official kind of qual. But yeah, that would be a nice thing to have. Definitely, we can do that. I don't see why not.
Yeah, I think you just
Certificate of
say
attendance is a good idea. Yeah,
that's right, in attendance and the number of hours spent.
that's a great idea.
You know,
Yeah,
and yeah, because we have to be careful about, you know, because some people, CPT is you know,
absolutely.
sort of specialised.
Yes, and as you know, we're not advocating as a professional qualification. You know, it's not an alternative or a substitute, you know, to that. And I think that's really important to emphasise.
Yeah.
Are there any other? So there's quite a few questions in the general chat to pick up.
Yeah, I've tried to.
I can take a sort of copy and paste and then just pop them in a document so we capture everything. That's what I normally do, so that we can retrospectively answer some of them because of time.
Fine. Yeah. And we'll concentrate specifically on the heat pump ones, I think. I know some people are
of course,
about solar panels, but I might make a brief mention of things like that. But
yeah,
things to do with solar panels, but it's slightly off topic.
it is. I know. Yeah, you're right. I think it's difficult. We have to kind of balance it because of time. But maybe if we've got this time to answer more general queries, then why not? I guess.
Well, this is it. Yeah, let's see what happens, and you know, we can start getting that in, because it's in one respect it's off topic, but in the other respect there's the thing about the whole energy.
Yeah.
You know, it's a holistic view in a way with energy.
Absolutely. Yes. Absolutely. I think that is important because these things all connect up. But you've done really well with time. I think we've done pretty good.
All right, thanks. Yes, I've not bad, but I was thinking I'm a bit rusty. I think it's about 3 years since I've given a presentation, actually. I stopped. I used to do a lot of work a lot of work. I used to do some work at Stuttgart University, go over there once a year. But yeah, so I hope that I've come over okay.
Yeah, it's been really good.
Good.
So some people are returning now, I think, from the break because we start in a couple of moments. Is that okay with you, Andy? Florence?
Yeah. Did we say 5 past?
Yes.
I think, yeah. We'll wait until 5 past and then start.
Chris has said also idea of internal temperatures. A few people have asked, and great presentation. That's really nice.
Oh, right. Yes, I will talk about that because I have a story about internal temperatures.
Okay.
Partly that I used to keep them at about 18, but as I get older, I've upped it a bit, so it's 19 and 20 and whatever now, which you know. But luckily, actually, because the system has been slightly improved, so I think I'm getting you know, the same sort of results as I used to have, but with slightly higher temperatures.
Mm-hmm.
But I really need Tristan to put me in a new monitoring system.
Yeah, because they did that kind of impact your monitoring then since Mitsubishi paused everything?
Well, yeah, I mean, I don't know whether I'd mention it at all to everybody, but I had a big problem with Mitsubishi because they closed the monitoring system and said, and so I talked to them. They said, well, if you want a monitoring system, we'll sell you one, and it will cost about £1,000. So I bought it, and complete rubbish. It really was. It took them months to get it, so I could get any sensible readings out of it at all.
Maybe that was their strategy.
Well, yes, the whole thing, you know. It was a shame, really, because I mean, there's still people in Mitsubishi that I like, but clearly there was well, clearly there were problems in Mitsubishi. In fact, problems with a lot of,
Great.
because I'll start from that again.
Wait, yeah. Are you on to reflections or the one before?
Was the one about comfort? Yeah,
There we go.
There we are. That's
Here
it.
we are.
Comfort. Right. Okay. I'll just go through this again because I got. Yeah. Just okay, folks. I'm assuming everybody's back. So I'm going to talk. Well, this is the slide we had before about comfort, and as I said, warm feet, cool head works. It's very pleasant, and that's the benefit of underfloor heating. And I said about a stove or another type of heating system is a good adjunct to a heat pump, and I'll explain why in session 3. High thermal mass means that you can turn your heat pump off for hours at a time, and you don't have to worry about the temperature inside the house going down. Okay, next slide. So reflections. What I try and do is during the spring is to run the heat pump between 2 and 4 when just a little bit of heating is needed. So you've got maximum heat from the day, and also you've got maximum input from the panels. And yeah, grid input will always be needed for heat pump. Well, unless you've got a wind turbine, you might be okay there. But small wind turbines tend to be inefficient. And what I haven't included in my calculations is the electricity needed for media and appliances, which is, possibly another 1 or 2 megawatt hours. And so I'm planning actually to put up more PV panels, and I'll be able to increase my the input of energy and try and make my house, well, there is a European standard for near zero energy buildings, and I would like to think that my house could achieve that eventually. And finally, customized integrated system is effective. Integration being integration between installations, solar gain, thermal stores, and an efficient heat input. Yeah, efficient generation of heat. I should have said energy input. Well, the energy input from the PV panels, which can at the right time go directly into the heat pump. Okay, next slide. Here we are. Here's a vision of a low carbon future. We can't have vast areas of land taken up by wind turbines and PV panels. So we have to reduce the amount of power consumed in dwellings. So we should be looking at dwellings becoming energy autonomous. Again, as I said, if people want to read about that, if you put in European Commission and NZEB, near zero energy buildings, you'll find masses of information about that. I might put up some of the websites myself if there's, if we've got a space to do that. Yeah, I've tried to demonstrate how this can be achieved. And I have said that, the other thing about woodland is it's a great ecological resource. I'm really fortunate that in COVID lockdown, I've had all these trees all around me, loads of birds. I've seen all sorts of other animals. I had a weasel within 6 foot of me, doing its social distancing. And then I've had a deer, which was a bit of a nuisance, had to get rid of that. And squirrels, all sorts. So it's actually, I get a bit of company in me lockdown. And I'm a big fan of Red Rose Forest, which is an organisation which manages forestry in the Manchester area. And I've talked to them about, supplying of wood from their bits of forest. But that's actually, I'm going a bit off topic here, so I'll leave that. Right, I think that's about the end of this. So last slide. Oh, all right, thanks. Yeah, okay. John Cantor, as I mentioned him before. Nick Parsons, you'll hear more about him in session 3. I think somebody asked a question about knowing about how much energy your building is putting out, or heat is putting out. So what you want to know is, if it's 20 degrees inside and 0 outside, how much energy, how much heat is going through the walls. And Nick Parsons was the person who did my energy audit. I will recommend an energy audit before you get a heat pump put in, because then that'll enable you to size your heat pump accurately. But I'm dealing with that in session 3. Peter Wilkinson, who's now, I think he's now chair of the AECB, built my extension, so thanks to him. World Heat put the installation in as it is now. Mitsubishi were great with the heat pump monitoring to start off with, but I have since then also got heat pump monitoring from, well, not heat pump monitoring, some room temperature monitoring from Tristan. And I have talked to Tristan and John Cantor about getting monitoring for my heat pump. And then Keith Trippier, he's a great guy who actually is more than 36 years, over 40 years now. He was an apprentice in a class that I taught, and he's now, 60 odd or something, still doing work up here, which is great. Really nice if you can get people who you can rely on to help you in this task. I've mentioned Lubo Yankovic. I worked with him a lot academically, and he has done a lot of interesting, if you like, development of ideas in the area of retrofit. For instance, he's come up with the idea that there are 40,000 different types of retrofit you can do to a house. I'm not going to go through the details of that, because obviously it depends on what you think is a different retrofit. But what I will leave you with is the idea that there's not a one solution fits all issue. There's no silver bullet to retrofit. We have to look at all the issues. Okay, next slide. This is my house in 1977 when I first bought it. It's still looking a bit derelict. It wasn't lived in for 20 years. And the first thing I had to do was dig out the sheep manure, because it was a foot deep in sheep manure. I had a nice Morris 1000 van, which is on the left-hand side. And if you look closely, you'll notice it's a foot off the ground. I had to raise all the suspension off the ground so it could cope with the terrain here. Anyway, that's by the by. So essentially, we've finished the bit where I'm, presenting, and then we'll go on to a Q&A. Yeah, I'll just do these quick slides. Integrated approach is important, but perspectives differ depending on your viewpoint. So next slide. This is a little thing. For those who haven't remembered, Lance Armstrong won the Tour de France 7 times, but then all his titles were taken away because he was found to have been, over the years, just taking drugs. So if you want to read that. I just thought it was topical when I first did it in 2014. But there you go. Anyway, right. So, yeah, so I'm quite happy to, talk to people, answer questions.
Can I pick out a few questions for you, Andy?
Yeah, do. Yes, you should fire the questions at me.
So, relating to your particular situation, some people were thinking about the thermal mass.
Yeah.
Where exactly did you say the installation was? On the inside of the property, or on the? Is it cavity?
My insulate. Oh yeah, no cavity. It's a solid stone wall, at 550 millimeters thick. It weighs about 1 ton per square meter. Now, on the north side, there was actually, for some reason, there wasn't much insulation on the north side. There is some. So when I put the extension on, that just took off about 28 square meters of wall, which then gives out heat into the kitchen and then the other way into the other rooms in the house. So it's now an internal wall. So that's where I get the thermal mass from. For the other walls, I've put insulation on the put it in internally, because with a dry stone, with a stone walling, external insulation, it just spoils the character of the property. So it does mean that I'm losing a lot of thermal mass. Well, in a way, but it's still there. So it is still acting as thermal mass, but of course, not in quite the same way as if the insulation had been external.
Sure. So you've got a lot of thermal mass within the house anyway, with your internal walls and things.
Right. Actually, there's a question come up here about somebody who's also got a 1750 house. There are all sorts of different ways of treating them. You can put breeze block walls internally. I've seen that for 1 or 2 buildings where they've actually almost built a building within a building. This can be a solution. It works very well with big barns. My house isn't a huge house. It's about 115 square meters. And if I was putting internal walls in it, I would, be seriously reducing the size of the rooms.
Great. Quite a few people, I think, might have been given quotes for heat pumps, and they're worried they're oversized. I think that's quite common, isn't it, Andy?
It's very common, and what I would do is say, do you really need one more than 5 kilowatts? If you have a big house, you do. Incidentally, I will come on to this later, but my answer to heat pumps is just have 5 kilowatt ones. If you've got a really big house, get 2 5 kilowatt heat pumps, so you can run one of them most of the year, and then during the winter when it's really cold, run two in tandem. And that way you can get very good efficiency out of the system. But
Yeah.
again, that's something we'll talk about in later sessions.
It's a good
Yeah.
tip. Chris has got his
Also,
hand up as well.
But before we
I was
leave
just
that
saying-
topic, the other
Yeah.
thing is, do get a really good energy audit. If you can get Nick Parsons to do it, great. But there are other people who can do energy audits, but make sure you get somebody who's good in that area. I think Liam actually might have something to say about that. Am I right?
Yeah, Carbon Corp offer like a My Home Energy Planner service, and they also, Liam does like an initial scoping service as part of the retrofit journey. So yeah, there's a kind of a two-phase process, but the main sort of My Home Energy Planner service is really in depth. So I think that would
Right.
probably be a really good protocol, and it would produce a report that's incredibly useful for householders who might want to do incremental changes or go for like a really, you know, large retrofit, or just do things bit by bit, like we discussed. You know, I
Right.
think people, like you said, one size doesn't fit all, does it? So I think having that
Exactly.
information is crucial, but then you do with it what you can. So
And the more information you get, the better. I got I think it was a 14-page thing from Nick Parsons,
yeah,
partly because I really wanted the detail, and it's really helped me in terms of putting the insulation in the right place and so on.
yeah,
Yeah, it depends how much effort you want to put into it, but the more you do, the more return you can get if you're working with the right people.
yeah. I think the My Home Energy Planner reports tend to be around 40 pages. Sometimes it can be up to
40 pages.
90 pages if it's a really
Really?
big
Oh,
house.
wow. Yeah, okay.
So they go really, really in depth. I think
Well,
absolutely all
great.
the details in there.
The more you can get, the better.
And it's a one-time only thing. So yeah.
Well, this is it. Yeah, and then you know what your house is doing. I did actually have my house because I work with thermal scanners, and we scanned it with a thermal scanner
It's
to
interesting.
but actually which was interesting because I could see where the heat was lost and whatever.
Absolutely.
But yeah, but again, that's another topic.
Sorry, Florence was going to come in with fielding some more questions. I
Oh
think
yeah, carry on. Yeah,
some
yeah.
people have got hands up.
I was just going to mention that session 5 is going to be an interactive session, and if people have quotations and particular problems they wanted to have a look at, we can they could send those in and we can try and address those in session 5 if it's not too late for them.
Yeah.
Or they could get in touch. Rupert has asked what happens if you fit a heat pump in an unreconstructed Victorian house. I'm assuming that means not insulated. Any rule of thumb for whether you get an acceptable result?
Yeah, you do, because ironically the heat pump works better because there is more heating demand from your radiators and whatever, so that the heat pump is then going all the time. The compressor really likes to be working at its maximum output. If it's less than maximum, it goes down to 60% in the end before it turns off. So yeah, I mean, in a way, that's what I did with my house. I put the heat pump in and then put quite a lot of insulation in afterwards. And I said, right, I'm going to put this heat pump in. It's going to be a small heat pump, 5 kilowatt. And then my task then is to insulate the house until it becomes comfortable. And in actual fact, now I could have a smaller heat pump, a 4 kilowatt or a 3 kilowatt heat pump, and it would still, be sufficient for the house. So I would say that's not a bad thing to do. Of course, the thing is, you want to decide whether you're going to put insulation on the wall before you put the radiators on, or put new radiators on. But yes, no, I think, why not go for that? But
And
get an
yeah.
energy report.
The idea of it being sufficient. Some people were wondering what temperature you heat your house to.
Right. Yeah. I did heat it to 18 degrees. Now remember, presenting to people. This is about 6 years ago, and they thought this was a bit cold, 18 degrees. But in actual fact, I'm over 70 now, and so I tend to the temperature creeps up. So it's now about 19, 20, and I find that a comfortable temperature because I put the extra insulation in. The heat pump copes with it very easily, actually, because I don't. If I've been away for a few days, yes, you know that the room's cold, and I'll get the stove going. But if I don't go away, it's not a problem. You know, it just copes with it very easily.
One thing, Rich. Oh, sorry,
yeah.
Florence. I just
No,
noticed related to the stove, Richard Eskeen did actually say in the chat that he realised it's obviously a personal journey and story, but shouldn't homeowners be aiming to not have the need for backup sources like the stoves, which, you know, we've talked about how you're offsetting that with like local coppicing because you've got your own wood burner,
Right.
you know, down burner.
I would disagree. I urge anybody who's interested in this to read the BRE report on this, because I'm not saying everybody should get a stove, but the interesting thing about the BRE report is that it says if you use direct electric for the really cold days when the heat pump, you know, might not be sufficient, it's actually more efficient over the whole season, counting the direct electric heating with the amount you're putting into the heat pump, okay, than it is if you had a heat pump that, if you like, exactly matched your requirements or was slightly oversized.
Great.
Now, a lot of installers say, well, it ought to be well oversized so that when you come in and turn the heat pump on, then, you know, the heat pump is getting you up to a good temperature quickly. Well, if you do that, you have an inefficient heat pump. And I would say, you know, get a fan heater. And so if you're coming back off holiday and you want to get the heating quickly, you've got your fan heater, turn it on, and use that while the heat pump is warming things up. The other thing, of course, is nowadays you can turn your heat pump on while you're on holiday if you've got that system. I haven't got that system, but I know people have. I think Tristan has a system where you just sort of use your phone to turn on your heating system.
Yeah, like a smart.
Michael had a couple of questions. One was about, do you find you have much of a problem with your evaporator frosting up in the Pennines? And does the Mitsubishi unit have an automatic defrost cycle, which I assume it does?
Yeah, it does. I mean, well, it depends on what type of heat pump you get, but for the better heat pumps, the frosting up evaporator is an old problem. You don't get it anymore. Basically, on a Mitsubishi, when the temperature goes below 3 degrees, it will spend, say, about 5 minutes an hour doing a reverse cycle, heating the whole system up to get rid of any ice that forms. As I'll tell you later, the wonderful thing about the Mitsubishi system is that you just put it in and forget it. I've had mine 10 years, and the actual unit, I've done nothing to it at all apart from clean the air intake so that, you know, the air gets in smoothly. If you've got a clogged up air intake, it can be a problem, and all you need for that is just a jet of water.
Great. And the other question was about domestic hot water. So I'll be covering domestic hot water and the options in later sessions. But Andy, what do you do about
Right. Okay. Domestic hot water. I don't have domestic hot water off my heat pump. When I was planning it, I decided to keep it simple in the end. So I do have domestic hot water. I could get it, if I had batteries and whatever, I'd do it through the PV panels. But at the moment, yeah, it's extra electricity, partly from the grid, partly from the PV panels. If you talk to Tristan about that, he will tell you more about it. Tristan has, I think, more engineering experience, certainly more installation experience than I have. I couldn't install my own system. Tristan did his. He worked with John Cantor, and I think he's got a very clever system you'll hear about next week, which does have domestic hot water. So he's probably the person to ask that question to, right?
Thanks, Andy. Is there time to launch one of the polls? Because sadly, because we kind of went through quite quickly and the interval then was a bit later, I completely forgot that we actually had those, and I can't launch them. Or do you want to finish going through the Q&A? What's everyone's thoughts? We can always send the polls as an email to people after the session.
I think an email afterwards.
Yeah, it's better to deal with the questions that are left as well.
Okay, yeah, next question.
So can you cite the EU standard for near zero homes?
I used to be I was very familiar with it at one time, but the standards actually are quite interesting because they're very flexible. That what the near zero energy buildings document says is there's all these different ways that you can achieve a near zero energy building, and that I think it's a great document because it looks at it and it sort of says, well, if you have, say, for instance, if you're in a windy site and you want to put a wind turbine up, that's fine. Put PV panels up, okay, and yeah, all sorts. So I think it's something you have to look at. I did actually just the other day. I found, I had a look at their website, which has got some more recent stuff on it. This is, mind you, when I say it's recent, the whole thing's ongoing. This is something that's started off, I forget whether it's 2000 or 2003, and is added to sort of month by month, year by year. Yeah, they have a lot of sources of insight, on-site energy that they'll describe, that you can use to make your building near zero energy.
Great. Wynne asked, they have a solar eye boost to send surplus electricity from their PV to the immersion heater.
Yeah.
Is there a device to drive an ASHP harder with surplus energy?
Not to drive it harder.
No.
No, I mean, because they I don't think you can boost an air source heat pump in any way. I think what happens is if it's got a sufficient load, I mean, if you want to boost your air source heat pump, you put bigger radiators on it and more underfloor heating, and then it will, if automatically, it will need to supply more energy into the water that's flowing around the system, and so that will drive it harder. But actually, the amount of electricity that's available is not, doesn't affect the performance of the heat pump unless it's got less than it needs.
And Tony asked a question early on: if you have a water borehole for potable water, could you use this as the source for a water-sourced heat pump, or would you need to drill another borehole?
Well, if you've got
I would say,
oh, that's interesting. You've actually got a water borehole. You could use it as a source of a ground source heat pump. I mean, this is something I looked at, but because the price, I mean, if you have a borehole and you're using it as your source of water, it's worth investigating whether you can put water down there and then, you know, and get it some heat into it while it's in the ground, and then put it into your system. Yeah, that would actually be classified as a ground source heat pump. Although, yes, I'll take the point that it works off the water that's flowing through the system. So yeah, it's a valuable resource, a borehole. So it might be worth exploring that. I mean, that's one of the problems with ground source heat pumps, is that you either have to spend an awful lot of time and energy digging big trenches to put pipes into, you know, take the heat from the ground, or you need boreholes at £5,000 a go.
yeah. And somebody has asked whether you considered a ground source system.
Oh, I did. Yes. I mean, I've got the land for it as well, but when it came to it, two things put me off. One, that I'd have to do a lot of digging, and, you know, levels were interesting because I'm not flat. And the other thing is that you can put all this stuff in and you've got loads of piping to, you know, a metre below the ground or whatever. And then you get an airlock in the piping. And you've got real problems. I mean, the ground source heat pumps are seen, certainly by the government, as a sort of a better option, as it were. But if you've got a really good air source heat pump, because a properly made one, all the, if you like, the working bits are in a factory manufactured box, and therefore you don't have to depend on, you know, what somebody's done when they've laid the pipe and they've got it wrong or whatever. So I'm actually in favor of air source heat pumps, apart from if it's a new building, when you can, you know, you can do the excavations for the building and for the heat pump and get it right, you know, and get the levels right and whatever. So yes, I'm in favor of air source heat pumps, but I have actually, the last investment I did with, you know, money from my pension, I put it into a ground source heat pump firm, because I got a really good rate of interest, because it was heat pumps and people were a bit suspicious of them. So, you know. So yeah, I'm not against ground source heat pumps.
Yeah. There are quite a few questions on how to calculate heat losses and the size of your heat pump and that kind of stuff. I think I'm covering that, aren't I?
I think that's later sessions, you know. I'll certainly mention it in session 3, but then it'll probably go to session 5, won't it?
I think it's going to pop up all throughout in session 4 as well, with the retrofit. And I think Tristan references it in his design brief on his study.
Yeah, and I think it's a topic too where, I mean, you were talking, Polly, about a 90-page report.
Yes.
I don't think we can cover that type of stuff.
No, that's the extreme end. That's the extreme end of my home energy plan. That's a very.
I mean, this is it, and there's an awful lot to calculating U values, and then of course, as you know, you can go into airflows as well,
I think if people wanted to do this, they could look up John Cantor's website, and I think it's got a few pointers on how to do that, but we will cover it, obviously. in future
Right.
sessions.
Yes.
Yeah.
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 Can't do it all in one session, so
Yeah.
that's why we
And
got 5.
be interesting to see what Liam and Marianne say about it, because that is clearly a retrofit issue. You know,
Yes.
you want to put in stuff which gives you the most, if you like, heat loss reduction, and so that's an important calculation. But if you like, it's sort of the other side of the equation. I'm not well. Okay, we will be concerned in this course a bit about this reduction of heat loss, but I think we're probably more concerned with the heat pump, and assuming, you know, well, I take as a yardstick that if your house is not a huge house, you ought to be able to get it down to a 5 kilowatt heat loss.
As a
And
rule of thumb. Yeah.
Another question, or
Do you want to just have a quick read of the Q&A, see if there's anything that you can answer now?
I can't see the Q&A at the moment, so what do I
right.
do?
I'm not sure. Do you want me to share the screen?
Oh,
so you
there's
can
the
see it?
Q&A. I do want to put it
Found
on
it?
the screen.
I
And,
can do a screen share of it.
right, okay.
There we go.
Right.
So there's Michael, Paul Hadfield, and another one. Are those because everything else, Florence has gone through 26, so it's pretty good going. Well done. So they're not so much questions as sort of partial statements, I think. The value. Yeah.
I'm reading one from Michael here, which I think is quite interesting about having zones in your house.
Yeah.
Because I do know, in fact, from that's one thing that Nick Parsons did. He has a big Victorian house, and I remember, you know, talking to him in his living room, and he'd put a great effort in insulating the living room without changing the lovely Victorian character, because it was a very nice house he lives in. And so they've done that, and they've made a really well insulated living room, and it's a large living room. And so that's where the family sits. And it's a nice warm room, and the rest of the house is a bit cooler. Yeah, you know, I think that's a good solution. For myself, I have what I call buffer zones. I have areas that are slightly cooler on the outside of the house. I mean, that's one of the things with the conservatory. It's, as well as getting heat in, it's a buffer zone. And then on the other side of the house, I've got a porch before you go out to the back door, which has got washing machine and freezer in. And I think those buffer zones can be quite good in terms of reducing heat loss, because you're not heating them up to the same level as the rest of the house.
It's a good way of thinking about it. It's almost like a moat or something.
Yeah. Yes. Keep the heat out. Yeah.
There was something at the bottom from Paul on a question of detail, right, but one which may be relevant to others. If you're in the middle of as a specific case study with Paul's situation of an air tightness exercise, this will come up in session 4 for sure, right, and probably in Florence's session as well.
I'll read it a bit. So
yeah, I think the gist is
air tightness exercise. I'm not ready yet for heat as I am.
The pipes
Come on, put in the pipes for future heating while the boards are up. Well, there's no reason why you can't put them in.
Sort of preemptive.
The only thing I would say, if this is ongoing work, I always suggest to people put in 25mm pipes. Some people put small pipes in, and then they get upset when the pipes clog up because you've got the antifreeze in the pipe. So put in large bore pipes if you're putting them in waiting. Right, he says, in other words, are the Bryn glycol raw water pipe fairly standard, possibly open loop. Yeah, I had a sort of disagreement with the plumber because he told me that best practice was to put in 15mm pipe, and I said to him, well, actually I want 25mm pipe, and he turned up with 15mm pipe because he told me I didn't know, what I was talking about. And so that ended our relationship. He went back in his van with his 15mm
Dear.
pipe.
Well, I would just say that the system in your floor is separate to the system outside. So the system in your floor won't depend on your on whether it's a closed loop or an open loop. That's just the type of heat pump that you're.
Yes, that's right. The closed and open loop heat pump is that's a different issue. That's collecting the heat from outside, whereas we're talking about underfloor heating, which is giving out heat.
Yeah.
So
so if you know your heat loss for that room or what heat input you need, you can get an underfloor heating manufacturer to put those pipes in. In fact, they'll be different to your. Well, sometimes they'll be different to your heat pump supplier anyway.
Yeah, and I used standard 25mm hot water pipes, because why not? And just slap concrete on it. If you put in concrete on it, you can only run it up to 40 degrees. It's otherwise you'll start cracking the concrete and whatever. But I've found that good, and it was also what I wanted to do because I was used to concrete. I was at one point I was concrete quality control. That's another story, but you can do good, very cheap underfloor heating just with normal hot water piping and a load of concrete. Environment Agency has a good booklet which discusses borehole heat. Right. Okay. That's interesting. A lot of most of what I've seen from the Environment Agency is good stuff. So that might be an interesting. Mind you, boreholes can be very deep boreholes where you're getting thermal stuff, which is a bit different.
Yeah, there'll be a variation, won't there? We can collate these links, or I'll collate the links once I stop recording, because I'm still recording the after discussion because I think it's rich and important to have people's input and questions answered during the webinar still recorded. But I think I'll collate those and we'll send over.
I just answer Michael's. He said not insulating a Victorian house before installing a heat pump is not a good idea.
Yeah.
I actually put my house in before I'd finished the insulation because the insulation, to my mind, was a series of, insulate here and there and whatever. I'm in a way what I sometimes call a slow builder. I don't go for one big project. I tend to try and get right all the things that I do. And people who know me know that I've been working on my house for over 40 years. I said it was a 40-year project, but I haven't finished yet, so it's now a 50-year project. So it's tricky, the chicken and egg thing. Do you put heat? All I can say is if you put a heat pump in before insulating the house, have it so that its output is what is needed when the house is insulated. Otherwise, it will be hopelessly inefficient when you have put the insulation in. And it's right to say that you'd have a huge electrical load if that was it and you did no insulation. But it's a question. It's a good question, but not an easy one to answer.
Paul was just qualifying his.
All right. And so you're talking. This loop is what, for a ground source heat pump?
This is what I'm not understanding necessarily. I think
I'm not sure if it is for a ground source heat pump.
Yeah, so that's got nothing to do with that your floors are up, I don't think.
Yeah, exactly. It's not to do with your
Mm.
floors, because that's in the ground outside the building.
Unless you're underneath.
Right. Have we got other ones that were?
That was it. He was saying he's hoping to have a water source heat pump pool.
Well, then, I mean, yeah, for mine, I had this heat exchanger outside outside the house. In fact, it was I had a path, and you pulled up the flags for the path, and there was the heat exchanger. So that's all outside the house. Yeah. That's getting a bit techie. I think, you know,
There's
I
plenty
can
of time
talk
for
about
that.
it all the time. Yeah.
Yeah. I think you've done everyone's. Yeah, I think we've covered sort of the general gist. And I'm very mindful that anyone else, like you two, have probably things to do past 8, because it's getting on for 8
Right.
now. But I think we've done. I hope that we've answered everything as much as is possible now, and we can send follow up with, you know, some links for people based on the questions.
Yeah. My final words are: enjoy Tristan's presentation next
Which
week.
is next week.
Uh,
Yes.
I think it's a great installation. That the only warning I would give, and I've told Tristan this, he's a really good engineer. If you can do what he did, you're as clever as he is, right? So don't expect to be able to put a heat pump in and get it up to a COP of 4 straight away. But the guy knows his stuff. He is good. And I always find it interesting talking to him. So I think you'll find his presentation very interesting. And I think, when are we back? In August, aren't we? I think.
So we'll be coming back, I think, on August the 12th and the 19th, and then the final session will be on the 2nd of September. Is that right? I think it is.
Yeah, that's, I think that.
And we're the same time
right.
every week when we run them. So next week's is 6 till 7:30 again on the 22nd, just to keep some kind of continuity, so it's not too confusing. But we are jumping around a little bit with giving you a break in between. We'll set some not
Thanks,
homework,
Julia,
but some time for everyone.
Yeah,
Thanks, Julia.
Yeah.
There's time to absorb and reflect and come back on this, which is good. Thanks, Peter.
Thank you too, Peter. I mean, it's been a good session to me, because there's a lot of people raising questions.
Which is what we need.
We probably haven't covered them all in this session, but we have